Hi class, today we're going to talk about instances of classes, and we are basically going to be creating our own variables. So if you remember, a primitive is a variable that's built into Java, and it's often takes up very little memory, and what you see you get. There's no memory issues. It's just our basic things, and we talk about like integers and doubles. Those are common primitives. So today we're going to talk about new variables, which would be by reference. So they follow slightly different rules in Java. So I set up a file already called physics.java, and I gave it a main, which is what I need so I can run this program. And I can even go and I can test it. So I can say Java C physics.java and then Java physics, and it doesn't do anything because there's nothing in this space. Now, if I'm doing two-dimensional physics, very often my x's and the y's, I want them connected. So I'm going to make a new class, and I'll call that a vector. So I'm going to say file, and I'm not going to get too deep into physics, so don't worry about the physics part, but I'm going to say a new file. I'm going to call it vector.java. And now my vector is not going to be designed to be run on its own. It's going to be designed to be run with other files. So in my vector, I'm just going to have an x and a y. And you know what? I'm going to make them doubles because in physics we normally aren't clean enough to just have everything as an integer. So I have an x and a y. And I could put a z if I wanted a three-dimensional space. It doesn't really matter. And I'm going to say that these are both public. Now, eventually you're going to learn that I don't like doing this. Here, I would like to make these private, and you'll learn the difference between public and private. But for today's lesson, we're going to say these are public. Now, public means that they can be read outside of this file. And that's for public. So public means it can be accessed outside of the file. So here, if I wanted to now use this new data type called vector, I can say vector v. And it is almost that simple. There's a little more setup because it's not a primitive. So what I have to do is I have to say vector v equals a new vector. And now v is now an instance of the class vector. V is an object. So our class vector now has an object called v. I could have another vector called a, and that's also a new. So now I have two instances of the class vector. And what's kind of cool about this now is I can say a.x equals 3.7, a.y equals 4, v.x equals 10, and v.y equals v.x plus a.x plus a.y. And what I would do is I'd say, okay, well, what's v.x? v.x is 10. What's a.x? a.x is 3.7, and a.y is 4. So that would be the same thing as 10 plus 3.7 plus 4. And now if I say system.out.print v.y, we should get 10 plus 3.7 plus 4, which is what, 17.7. So now when I compile this, I do not need to compile vector and physics. I can just compile the one that has the main, And as the compiler hits objects that are being used, it will compile everything together. Um, sorry, Java C physics. That compiles, and that created a vector class. It compiled the vector class. If there was an error in my vector class, it would have thrown an error. But now I can say Java physics, and I get that 17.7 printed. So V is an object, A is an object, vector is a class. The class is the file that you're writing, and when we create a new instance of the class, we create new objects. And that is today's lesson. Hope this is helpful. Thank you.